Good morning. The first thing we're going to do this morning is learn about relative velocity. This is an application of the concepts you learned about last week regarding vectors, because relative velocity is much easier to do if you apply the concept of a vector. Let's take a very simple example. In this example, we have a man pushing a stroller at 2 miles per hour down the aisle of a train car. Now, it turns out in these problems, it doesn't matter if we're using SI units or US customary units such as miles per hour. As long as we're using the same unit in every part of the problem, that's okay. So that image there was the man pushing the stroller down the aisle of the train car. But this train car is not stationary, in fact. It is moving. Let us say the train is rolling forward at 3 miles per hour. So the question would be, how fast is the man moving and the baby moving relative to the ground? Well, that's easy. Most of us just do it in our head. We say 2 miles an hour plus 3 miles an hour is 5 miles an hour. But when you do that, you're actually doing a vector problem. You're adding the vector of the man's speed and the vector of the speed of the train car, should I say the velocity of those things. You're adding those two vectors together to get the vector of the man and the baby relative to the ground. Here it is in symbols. Let's say that VCT is the velocity of the child relative to the train. So the first subscript stands for the thing that is moving, in this case the child in the stroller, and the second subscript indicates the reference frame that it is moving relative to. In this case, it is the relative to the train. And let us say then that the train is moving relative to the ground with a velocity tg. So t is the velocity of the train, and g is the reference frame for that velocity. And then the velocity that we're trying to find is the velocity of the child relative to the ground, which would be velocity cg. The pattern we're going to apply in every single case is the velocity of the child relative to the train plus the velocity of the train relative to the ground is the velocity of the child relative to the ground. Now, in a very simple example like this, it seems kind of obvious. You just say 2 miles per hour plus 3 miles per hour is 5 miles per hour. But let's look and see how it works in other situations that are a little bit more complicated. Let us say, for example, what if the man is pushing the stroller in the opposite direction? Now how fast is the child moving relative to the ground? It's not that much more complicated. The man is still moving at the same speed, but in the opposite direction as the train is moving. And the train is still moving in the forward direction, as I've shown it here. So therefore, in symbols, the velocity of the child relative to the train plus the velocity of the train relative to the ground should give us the velocity of the child relative to the ground. So that would be a negative 2 miles per hour plus 3 miles an hour gives us the 1 mile per hour relative velocity of the child relative to the ground. Now, these examples seem kind of straightforward, but let us examine a situation in which we have the vectors not going in the same line, but going in fact right angles to each other. We're still going to use the same pattern though. The velocity of object A relative to object B plus the velocity of object B relative to object C equals the velocity of object A relative to object C. And they're all vectors, so when we add them, we're going to have to add them using vector addition. Let's work on an example. So imagine we have a ferry crossing a river. The ferry is heading north with a speed of 2.5 meters per second relative to the water, and the water is moving to the east at 3 meters per second. That's the flow speed of the river. What is the boat's velocity, the ferry that is, relative to the earth? So if you were to add those two vectors together, Ferry relative to water, water relative to the earth should give you ferry relative to the earth. But you have to add them together as vectors, and so your 2.5 meters per second ferry relative to the water vector should be drawn going in the northern direction. And then perpendicular to that should be another vector representing a 3.0 meters per second velocity of the river relative to the earth, or the river bank, some people say it like that, should give you then the sum of those two, the tip to tail vector that is the sum of those two vectors, should be the velocity of the ferry relative to the bank or the earth. Go ahead and figure out the result here using geometry and start it back up once you're done. You should have found out that the relative velocity of the ferry relative to the ground or the earth is 3.9 meters per second at an angle of 40 degrees north of east. So I have 3 short practice problems for you to work on and a link on the coming up page on Canvas. Finish up those really quickly, and then we will review or start learning about another application of motion in 2 dimensions called projectiles.